Today what we will do is this question from the sample question paper printed by CBSE. This question is from the topic of force on a moving charge, but it's a very different type of question, so I thought it is very interesting to do this. See, it is very important for you to start practicing previous chapters also apart from the ongoing chapters, because there is a good tendency for students to tending to forget what has been covered so far. So keep watching my YouTube channel. You will find some very interesting and very useful material for your upcoming board examination as well as the upcoming entrance examination. So let's start discussing this question now and read it first. All right. Our first ritual is to always read the question carefully, and even I tend to forget that. Alright, so there is a boy who's holding a smooth, hollow and a non-conducting pipe vertically with charged spherical ball of mass 10 grams carrying a charge of 10 microcoulomb. Is it micro? I think it's milli. Micro would have been this. Okay, so inside it, which is free to move along the axis of the pipe. So it's a vertical pipe. Okay. Let's draw a vertical pipe. I think I'm drawing it an angle. So I'll just rub this off and let's try and draw a straight line at least, right? So this is my vertical pipe. Let me just concentrate. Okay, so this is my vertical pipe. Inside it, I have a 10 gram spherical ball. Okay, so this is my 10 gram spherical ball and it has a charge of 10 millicoulomb. The boy is moving, the mass of the ball is 10 gram. The boy is moving from east to west direction, okay? In the presence of a magnetic field of 2 Tesla. So if I draw this diagram, right? So this is east to west. So the boy moves with the help of the pipe. So if the pipe is in the hand of the boy, the boy said this is your pipe, right? And the boy is moving from east to west. Okay, this is my east and I'm moving towards west. This is my vertical pipe. It has a spherical ball inside it, right? Now the question is, what should be the minimum velocity? Okay, this is important. What is the minimum velocity so that the ball does not move along the axis? Okay, now we know the boy moves, which means the velocity of the boy's velocity will go to the ball itself. So the ball will generally like to go down, and there is a magnetic field also, right? So the magnetic field could be inwards, could be outward. We need to decide that. But the point is, why is that the ball will not move? What is that condition, right? So we know about equilibrium, right? So we want a counter force here like this to balance the weight. So we want an upward force. The velocity of the boy is the velocity of this charge, right? So the boy is moving with certain velocity. The ball will also move with the same velocity, which means the QV cross B, which is the magnetic force which this ball is experiencing, which is obviously upwards, has to be equal to mg. Now, yesterday what we discussed was the right hand rule. I use my whole palm, right? So my velocity is in this direction, okay? And you can use your right hand and move from east to west. So I'm moving from east to west. My palm is facing down. My fingers are the magnetic field. If it is inside, the force will come down, right? The force is drawn perpendicular to the. So I'm moving from east to west. My fingers are downward. Inward inside the screen of this computer. The force is coming downward. We don't want that. What we want is that the force should be upward if we move from east to west. So this particular magnetic field should not be inside, rather it should be outside. that will reverse the direction of the force. So the magnetic field should be outward. Okay, that's one conclusion I have, right? Should be outward. This 2 Tesla should be outward, right? If I draw axis like this, okay, this is my gravitational field mg, this is my qvb force on the y-axis. In the x-axis, I'm moving from east to west. I'm sorry, I should have shown west here and east here, and the motion is in this direction, right? So my velocity is in this direction. Velocity is in this direction. My force, okay, is upward, which is only possible, this is x-axis, when the field is in this direction. So you can, match the direction with the help of your hand. I used the reverse logic. My magnetic field is inside. My velocity is west to east. If I use this, okay. Now what I do is, my velocity is from east to west. My magnetic field is, this is fixed. The direction of velocity is fixed from east to west. Magnetic field is inside, the force is coming down. So the only way I can reverse the direction of the force from downward to upward is if I change the direction of the magnetic field. Okay, so the magnetic field should be outwards. Okay, so this is my outward magnetic field, which will fetch me the magnetic force which is acting upwards. Now let's talk about this, right? What is the minimum velocity? So we know the charge is 10 into 10 raised to power minus 3 into velocity we have to find out. B we already know is 2 and mg, right? So this is 10 by 1000 into 10. Okay, so we have to find the value of this. So this becomes V is equal to 100 by 1000. 100 by 1000. Let's complete the calculation. 100 by 1000. Okay, multiply by. So this will come down. So this will be into 10 raised to power minus 2 into 2, right? So this is 10 into 10 100. This is 1000. This is 10 into 2, right? So this will come down 10 raised to power minus 2 and 2. So this becomes how much? This becomes 1 by 10 100 into 2 10 10, and this becomes 5 meter per second. So the answer to this question is 5 meter per second. That should be our velocity. So use your right hand rule. If you're not comfortable with this, use this rule, right? So you can decide the direction of the magnetic field, the velocity, and the force. The force has to be upward. Okay, if the magnetic field is towards me, my velocity is in this direction, the force is coming out to be upward, right? So I can use my normal right hand rule also to establish. If you're not comfortable with the palm rule, use the finger right hand rule, right? So this is my velocity from east to west. This is my finger, middle finger, which is coming towards my face, outward. My force is upward, right? So this is the answer. So you can see when you do these questions, there are two aspects. One, you have to find the magnitude. The other is direction. Most of the students are good at finding the magnitude without taking care of the direction. So whenever you do any physics question, please note the direction is also very important. And to find the directions, the cross product rules, the dot product rule, the resultant vector, all of those methods are very important. And therefore, the knowledge of vectors to solve physics problem is required. I have a playlist out there which explains all the vector knowledge you need to solve physics questions. Okay, I have tremendous emphasis on the ideas of direction. I mean, no direction, no physics. That's my motto. So please go and watch that playlist also. Electrostatics already has some exam-centric questions from books like Resnick-Halliday, NCERT Exemplar, NCERT University Physics, Nelson Parker, Conceptual Physics by Hewitt, and so many other books. So don't miss out on any of those questions, right? They are going to help you understand how to attempt a physics question. So I've put in a lot of effort to explain the questions, and therefore I believe that more is the explanation, better will be your conceptual understanding. Thank you very much, and wait for my next video.